Find an expression in terms of x, y, and a for the gradient at any point on the curve x cubed plus y cubed equals to 3ay squared with a as a constant. Hence, find the equation of the normal to the curve at the point where y equals to 1 over 3a. So let us differentiate x cubed plus y cubed equals to 3ay squared implicitly. Differentiate x cubed with respect to x. We're going to get 3x squared plus differentiate y cubed with respect to x. We're going to get 3y squared dy dx equals to differentiate 3ay squared with respect to x is 6ay dy dx. Let us divide this equation by 3. Then we're going to get x squared plus y squared dy dx equals to 2ay dy dx. Let us collect all the dy dx. Then we're going to get 2ay dy dx minus y squared dy dx equals to x squared. Then we're going to have 2a minus y equals to x squared. And let us cross multiply y times with 2a minus y to the right hand side. And our dy dx is x squared divided with y times with 2a minus y. This is an expression in terms of x, y, and a for the gradient at any point on the curve. Now, let us find the equation of the normal to the curve at the point where y equals to 1 over 3a. Let us substitute y equals to 1 over 3a or a over 3 into x cubed plus y cubed equals to 3ay squared. X cubed plus a over 3 cubed equals to 3a over 3 square. X cubed plus a cubed over 27 equals to 3a times with a over 3 squared is a cubed over 3, and let us times with 9 over 9. We're going to get 9a cubed over 27, and let us bring a cubed over 27 to the right hand side. It is equals to negative a cubed over 27. Then our x cubed is equals to 8a cubed over 27. And if we cube root both sides, we're going to get x equals to cube root of 8a to the a cubed over 27 is 2a over 3. Now we have a point of 2a over 3 and a over 3. Let us substitute into our dy dx just now, which is equals to x squared divided with y times with 2a minus y. We're going to get 2a over 3 squared divided with y, which is a over 3, times with 2a minus a over 3. Then we're going to get 4a squared over 9. Divide with, simplify this denominator, going to get 5a squared over 9. And if we simplify, we're going to get 4 over 5. This gradient of curve, which is the dy dx, is also the gradient of tangent. Let's denote with M1. We know that the gradient of tangents times with the gradient of normal, which is denoted with M2, is equals to -1. And the gradient of normal is -1 divided with 4 over 5, which is -5 over 4. Using the point 2a over 3, a over 3, and gradient of normal -5 over 4, we can find the intercept using y equals to mx plus c. Let us substitute the coordinates into y equals to mx plus c. We're going to get a over 3 equals to m, which is -5 over 4, and x is 2a over 3 plus c. Then let us simplify to find the intercept. We're going to get c is 7 over 6a. Using this point, the gradient of normal, and the intercept of 7 over 6a, we can form an equation of the normal. Y equals to m is -5 over 4x plus with the c, 7 over 6a. You can also write down as, let us simplify this function by multiplying -5 over 4x with 3 over 3 plus 7a over 6 times 2 over 2. We're going to get 12y plus 15x equals to 14a.